In this video, we'll clarify more the difference between the class and the instance namespace so that you really understand what's happening behind the scene when it comes to static variables. This is what we highlighted the last time. Now, remember what is a namespace. The first time we learned about the word namespace was in the functions when we were discussing the local namespace, the global namespace, and so on. Generally speaking, a namespace is a mapping from a name to object. Okay, remember we have names and we have values, so we would like this mapping. We visualized before the relationship between a name and value and the binding between them. When we have multiple namespaces, there is no relation between them. So this namespace might have the variable x and this namespace has a variable x, and both of them are assigned to different things. And so far the namespaces are implemented using a dictionary. When you define a class blueprint, you have a namespace for the class. When you define object 1, it will have its own namespace. If you define object 2, it will have also its own namespace. So these are three namespaces, and there could be even names common between them, but they are different things. Let's see an example. Here is a class of employees. I'm writing some documentation. I'm defining a static variable and have a method init and method print, and even have another method that is a class method. There is what we call the underscore dect underscore. This guy has the attributes of your object or used here. If you try to print object.dictionary, you will notice that you will have only a single attribute name, which has a value Mustafa. As you see here, the object from an employee here will have only the variable name, that's all. But it doesn't have, for example, the total employees. If you try to print the dictionary of the class itself, you will observe the following. It has a name for the doc, which is even showing my documentation here. It has also the static variable total employees, which has value of 1 from here at the moment because we created an employee. It has a method named init and method named print, and also it has our if, which is a class method object. As you see, the dictionary is very useful to tell you what kind of attributes this guy has. And by the way, you can add and remove from this dictionary and it will affect the employee class or the employee. You can remove things and add things on the fly. Python is a very flexible language. Now let's proceed more to get a sense of the namespaces. I have here I created object 1 and object 2, and I'm primed to print the total employees, which will be now 2, and object 1 total employees, it will be 2, and object 2 employees 2. Remember that here when we printed the dictionary, which representing the namespace of the object, we didn't have something called total employees. So how is it printed here? Here are the rules. Let's first define the namespaces. The employee namespace has many functions like here, but we care for now about the total employees only. So the employees namespace has a variable total employees with value now 2, which is in this address. Object 1 namespace has an attribute name, which has a value object1 in this address, and object 2 namespace has object 2 has name with object 2 and in this address. Observe here, so far we are just accessing the variable, and we can access a static variable from both a class or an object. But how the object is resolved as following in 2 steps. First of all, the Python interpreter will ask, does the object have this attribute total employees? The answer is no. It goes one step upper to the class itself. Does the class have the total employees in his namespace? The answer is yes, so it will be used. This is why this line of code doesn't generate an error asking what is total employees, because it is defined in the class itself. So again, there are 2 steps. First of all, is the attribute here? If the answer is no, it go and check in the class itself. Let's proceed more. In this line of code, we started to assign object.totalEmployees equals 7. Observe that, given that you have an assignment statement, this is a new rebinding statement. Okay, so I would like you to notice here, there is no total employees attribute in the class. Python is very flexible. You can add even attributes outside of the class. So this is a new attribute that is added to the class. So now in the object1 namespace, there will be a new attribute with value 7 in a different address. Observe here, object2 doesn't have this attribute named total employees. Object1 has an attribute named total employees. Employee class itself has a total employees. And a problem here is the total employees exist in both of them. When you try to print employee.total employees, it goes to the namespace of class and find the total employees printing 2. When you write object1.total employees, it goes first to the namespace of the object. Check out, oh, I have here a value 7, it's going to print it. Observe that any changes now you do to the total employees in object1 has no effect on the employee namespace. These now are two different attributes. As you see, once one of the objects started to have attributes similar to the class, it might be that problematic. So again, remember that the object will be asked first. If it has it will be used. Otherwise, this one will be used. If it's my attribute, then the changes here are local to me. It doesn't affect this guy or this guy. Let's take one more step. The object2 started to say total employees plus equal 3. Now, object2 didn't have total employees variable. This is again a rebinding, and the plus equal, like the equal, they will rebind here. The old value of total employees is 2. Plus equal here, this is as same as object2 to total employees equal object2 to total employees plus 3. So we first take a copy of the value here 2, plus it with 5, and assign inside the object a variable total employees named 5. Now observe that we have 3 different things named total employees. One of them for the class, one of them for the object itself, and another that for the second object. So now if you try to print object1 the total employees, it print this attribute. Object2 the employees, it print this attribute. But class.attribute, it goes directly here and print it. And any change in any of these 3 things now will not be the same. They are 3 different things. Let's go one more step. Let's go and delete object1 the total employees. Again, observe Python is very flexible to add or remove attributes. When you delete object1 total employees, it goes to the object1 namespace and remove the total employees from here. Now, if you try to print the class, it definitely will print it. If you try to print object1 total employees, it goes and search here. Does it have total employees? No. Then it goes to that guy and print it, and so on. Let me give you another example about the deletion itself. We here created 2 objects, employee1 and employee2, and then we assigned employee1 with variable 10. If you try to print 10, it will be 10, the local attribute of employee. If you deleted the employee.total, now you removed this local variable. If you try to print again the total employees, it will go back and get the class level. Now observe that I'm going even to delete the total employees from the class itself. So this total employees now neither exist on the object level nor on the class level. You cannot print it anymore. So I hope overall you got the sense of what happens when you started to use a variable same as the static variable name, attribute same as the static, or you did equal or plus equal in the object itself. It might be also educative to realize the case of the mutable objects. So far we were learning immutable objects. If you here define the list of 2 and 5, which is mutable, and you have here self.name. Now let's create 2 objects. Printing the list of the class or the 2 objects is going to show the same thing because these 2 guys doesn't have an attribute named list. If you wrote here object1.list equal 10 and 20, this is a new assignment. So object1 will have now attribute named 10 and 20. So the list and object2 will not be changed, but object1 has now a new list. If you come to object2 and wrote here plus equal 3, this means that the list of the class itself will be changed. So employee.list and object2.list will be changed here, as this is a mutable object and the plus equal is doing an in-place change. Observe that if the list was something like string, for example, the plus equal creates a new memory. So the class will not be affected, but only the object will be affected. So overall, as you see, the mutable might be a bit problematic. Now this takes us to another question. When to use the class attributes or the static variables? First of all, constants. Constants are very popular example for that. When you define a constant, you mean that no one is going to change or play with it, that we are all just accessing it. This is very good value. Another case, if defining some default values, let's say you would like to define some limitation value. So again, just the other guys are just taking the value and use it. So in these two cases, no one is modifying the variables. There are other two cases that you might see. Tracking. Tracking means like we'd like to keep some information about something. Let's say you would like to keep tracking all of the employees that has been created. Something like every time you create an employee, you append the name in some list for some reason. Another one is the statistics. You would like to know how many objects has been created, how many number of function calls has been created. I would like to provide you with some tips that will make your life easier. Access, modify the class attributes using the class name. As you see, if you use the object name, it might be problematic. Don't use instance attributes same as class attributes. Having a same name will make it very hard for you to guess what's happening. Avoid mutable data or for class attributes, or be careful about that. And again, about the dictionary, remember that we can add key and values and we can play with it. You shouldn't, but there are some cases where this is a bit useful. That's all.